It's going to be very difficult to treat the brain like a computer and control its state. But I think nudges are within our current technical abilities right now, where you can nudge the brain. And that can have meaningful results, I hope.
Yeah, nudge, but also predict when is, like you mentioned earlier, when's a good time? Is it
Exactly.
is it the phase of an ongoing oscillation? Is it during a particular phase of sleep or shortwave riffle, et cetera? So that's one approach. And then the second piece of the puzzle you need is what's the language? How are you going to nudge, right? Is it just going to be blasting it with this crazy amount of global stimulation, or is it going to be focused? Is it going to be hitting a network of white matter, which our results also suggest that that's important? Is it going to have a pattern to it? Is it going to be, a high frequency modulated, low frequency pattern that could induce more plasticity, et cetera, et cetera? I think as we learn more about this, we can be smarter in terms of how we're communicating and nudging the brain, as you say. And also, I'm very excited about deep learning and machine learning methods that are being used on these big data sets that hopefully we can gather in the memory field, such that we can learn, new information in terms of these signals that are communicating back to us and what they mean. And so in that way, find out better what, how to nudge or how to communicate back.
Completely agree. And, that's the big trend that I see the whole field is riding on right now, which is data science and, these very large data sets and using machine learning and artificial neural networks to mine these massive data sets and identify signals and biomarkers that can be useful for guiding our nudges.
So who decides when to nudge?
The AI.
Who decides?
But who trains the AI?
I'm serious.
So are we. So in our approach, the patient knows, or the patient reports when they're in a good memory state, when they're in a bad memory state. So if you give a patient 12 items, if they remember 6 of those items, by definition, they were in a good memory state for the items that were ultimately recalled, and they were in a poor memory state for the items that were ultimately forgotten or not recalled. So there's a patient self-report in identifying their own brain states. And that's the behavioral signal that we use to train our algorithms that then give the nudges.
So this is exactly what I'm interrogating. So we discussed a few minutes ago that it is a mystery how my brain absorb something and reject other things, and this is the key thing to think about. Is there a way you just switch on my brain or your brain and said, okay, in the next half an hour I will be on 100% absorption mode and I will learn everything, but then during those windows somebody should deliver messages, and who decides about those things?
I think this is where responsive neurostimulation comes in handy, right? You can look at endogenous signals in the brain and say, I'm going to nudge these further into the direction they're already going, for example, or do a minute correction to these. And so you're relying, by the time you're at hippocampus, I'm treating this like it's sequentially arriving here. By the time you're at hippocampus, you're in a really high order cognitive state. Like there's high order information. And if you can simply take the brain's natural processes and upregulate them, for example, I think that answers that problem itself in some ways.
I would echo that or amplify it and say, we're not saying that this device, this hypothetical device, is going to control your attentional process or control your emotional process. What we're saying is it may amplify the learning process, and you still have the ability to completely focus your attention on whatever is most salient to you. We're not going to be able to increase the learning of a completely random event that you have no interest in. And this comes back to, this idea of control of a brain state versus a nudge. That is, there's something endogenous in the person that varies on a pretty slow timescale from list to list that drives the performance variability. If we can nudge that process, I think we have a chance of significantly improving people's lives with deficits.
Can you give an example then? How would you envision that? I'd like to be better prepared for this podcast, and I have your instrument in my head, on my head. What would you do, and what should I do?
Yeah. So in our model, the patient, there's an initial training process, which is actually incredibly intensive. Patients are remembering lots of lists, and we're through those list learning studies, we're gathering brain sensing data from distributed areas of the brain, not only hippocampus, but neocortex, and using machine learning to identify those neural signatures that predict, or really it's predicting the brain states that allow patients to remember information. And what we find is those endogenous rhythms of the brain allow us to predict their performance. It actually allows us to predict with very high accuracy if a patient is going to remember the information that's being presented to them right now. It allows us to predict a minute later, 2 minutes later, whether they're going to remember the information in front of them. So once you've done that, then you can, you know when which brains, what the good brain states look like, what the bad brain states look like, and you can nudge the brain when it's in these poor memory states. And like I said, if you nudge it in the right place at the right time, it makes the brain state look more like a good memory state, and you actually improve recall without any effort on behalf of the patient. And again, that's Ezia et al. 2018.
Yes, but in that case, you are looking at my or the patient's brain state and said, oh, let's nudge it because I'm going to present blue. But that's not exactly what I'm interested in. I'd like to nudge my brain to those things that I want to attend to.
That's fair. In our publication, we were synchronized to only the encoding periods. We've since replicated this to, again, I do believe our results only translate to verbal memory. But again, this is the type of memory that is most impaired in patients with memory loss, such as Alzheimer's and traumatic brain injury. It's verbal memory loss that is the issue that causes them to have to leave work, leave school after their injury. And so we believe we can improve verbal memory through this training and nudging process.